make it. All right, there we go. Sorry, now I'm recording. All right, so today, Monday, June 22nd, I will answer questions on 8.3 and 8.4. 8.1 and 8.2, I know you guys turned in. I haven't had a chance to grade them because I was grading exams and they took forever, but they're done. All the sample exams are done and all the exams are done. The grades are in and posted. I emailed comment sheets to everybody last night about the exam one that was the Desmos version. And I already, for the PDF version of the sample exam, I've already written on everybody's sample exam and posted. Everybody good? Oh, let's talk about the exam scores real quick before I go any further. We all know that today after class, I'm just going to keep the class going afternoon and say anybody who wants to ask me questions about the sample exam and I guess the exam, you're welcome to stay after and I will answer questions. If you can't, then I can always meet with you individually in a Zoom. I will not record the exam portion. So I'll record class today, but I will not record the exam portion, but I will meet with anybody. You know, we can just do a one-on-one Zoom about your exam or whatever if we need to. Okay? Everybody good there? So today, if you can, stay after and I'll work with you guys on exam questions. If you cannot, that's okay. Just email me or text me and remind what time, you know, when do you need to meet, etc. We can go over whatever you've got. How are we doing? Thumbs up? Everybody good? Yes. Mirabelle, give me a thumbs up. Thank you, Mirabelle. Thank you, Lindsay and Emma. Waiting for the rest. Shayna, you good? CJ, you okay? Okay, cool. So that looked like almost everybody, except for I'm non-Christian. I don't know what's going on. Oh, there's something in the chat window that I can't see. Hold on. Okay, so that'll be exam stuff. All in all, you guys did really well. Did you guys all see the 5-number summary that I texted out? Yeah? So the 5-number summary, do you guys know what that is? Real quick. So the 5-number summary is the better way to show the spread of a data set. It always drives me crazy when people send out the mean. The mean is not a good measure of average, especially for skewed data, which exam data almost always is. So the 5-number summary, it was the minimum, which I sent it out for the exam. I don't know if I sent it out for the sample exam. I can, if you guys want me to, just text me. The first quartile, I said 25th, that's the 25th percentile. So 25% of the students scored below that score. The median is the halfway point. That's the average, if you want to think of it that way, which was an 84 for exam 1. So you guys did super well. Good job. And then upper quartile, that's the 75th percentile. So 75% of students score below that score. And then the max, which was the highest score, which I believe was a 93 on the exam. I can grab them real quick so you guys can see them. Give me 1 second. And then again, I'll go over individual questions and stuff about it later today. Hold on, let me just post this. Give me 1 second. Oh, good grief. Sorry, I'm fighting my computer here. All right, so oh, come on. Computer, I just did all of that work for nothing and you're gonna give me grief? All right. Oh, there they are. Ah, managed it. Haha. So this was for the exam, not the sample exam. Actually, I can tell you guys the sample exam. I've got it right next to it. Give me a sec. It actually had the same minimum and kind of a similar maximum, a similar 75th percentile. Where it was a little bit different was the 25th percentile and the median. So the one on the left is the exam, the one that was in Desmos, the one you got your grades for posted last night. And then this was the sample exam. There we go. Oh, can you guys all see that, or is it too small? Here, let me make it a little bit bigger. There we go. Everybody good? So you guys know where your scores are and where they fall into in that spectrum. But I'm very pleased with your median on exam 1. And honestly, your median on the sample exam 1, those are perfectly respectable scores. This is very nice. These are nice high 75th percentiles and maximums. So that's good. But you guys did super well. You should be proud of yourselves. It was not an easy exam, and you guys did very well. So, and again, we'll talk more about individual questions in it after class today. Everybody good with what those are? So if you're looking for like, what's the average? That's this score right here. The median is the average for our purposes. Anybody got questions on that? I'll wait in the chat menu, or you guys can unmute yourself and talk.
How are they weighted against each other again?
Oh, good question, Daniel. I believe I went 60% for exam 1, 40% for exam 2. That way they make 100% together. I'm almost positive that's what I did. Good question. Anything else?
When you say exam 1 and exam 2, which one's the sample exam?
No, they should both be exam 1 right now. So this is exam 1, and then this is the sample exam 1. This was worth 60%, and then this one was worth 40%.
Okay.
Exam 2 you have not taken yet. You're going to take exam 2 on the 6th of July in class, and you'll all have to have your cameras on so I can watch you. Won't that be exciting? Like watching paint dry? Is that okay, Maribel? So together, these two make your exam 1, if you will. It was more like exam 1 Desmos was this one. Oop. I can type. So this part was the Desmos portion, and this part was the sample exam. Is that good? Everybody okay? Sorry if I misspoke and said exam 2. I didn't mean that. All right, so that's that. So we'll leave that aside. So that, I know you guys hadn't asked those questions yet, but there we go. So that was just kind of a preview for the test. And then actual questions I'll talk about afterwards. And then I don't know if we'll have time to preview sections 8.5 and 8.6. We'll see how that goes. But you guys are going to watch 8.5 and 8.6 before class on Wednesday. And I'm going to warn you right now, and I warned you last week. 8.5 is, how's the word? Tedious? Tedious is the word. So, and 8.6 is no joke either. So 8.5 is, I don't want to say it's hard. It's more annoying than anything else. It's like, it's a lot of algebra. So it's called the method of partial fractions. So just be warned, you've got a lot of videos to watch there to get through those 2 sections, and you only have a couple days to do it. That's why I warned you guys to start watching them last week, because they were posted. These are actually already posted, these 2 as well, but don't even get ahead of yourself right now. Just stick with 8.5 and 8.6. Those are the ones that you watch for Wednesday. And then you are going to turn in tonight your 8.3 and 8.4 worksheets. So I assume that's where the bulk of the questions are going to come from, is the 8.3 and 8.4 worksheets, because those are due tonight, as well as your My Math Lab for tonight. And can I just give you guys a little shout out? You guys have done so good on my math lab. You really have. I mean, personally, I think it helps that I've limited it to, so it's only like, 7 or 8 questions per section, but you guys have done really, really well with keeping up with it. And I'm very pleased. I think it has really helped. I know it's tedious, but you need that extra practice to get good at stuff. So good job. Pat yourself on the back. You did good, and keep it up. Because you have more chapters to go. All right, so there's that. There's 8.3 and 8.4. So those are due tonight. 8.5 and 8.6, of course, are due for Wednesday, because those will be due Wednesday night. Are we good? And just a little reminder, your exam 2 is completely different than exam 1. It will have probably no Desmos in it, or maybe if there is a Desmos portion, that'll be like a take-home portion, but only be a few questions. And everything else will be in class. I will be watching you. You'll have to turn on your cameras and show me your area, and I will be proctoring you. Everybody's good. Anybody got questions? All right. Yeah, well, we're all set. Thank you, Lindsay. I was just about to ask, Lindsay. Thumbs up me. Are we good? Everybody okay? Thank you, Connor. Thank you, Daniel. There we go. We got Gez and Shayna in now. Good. CJ, Amna, you guys okay? Amna said all good. All right, cool. All right, good. Then let's move into questions, should we? Unless you guys want to work together in groups on them. I didn't think so. Not an A3 and A4. We might do group work next time, or actually, we won't do it until after we're through these sections. These are the worst. These are so tedious. So I feel your pain, my friends. I too have been a Calculus 2 student having to learn these things. All right, so I see Mirabelle's got some questions. Anybody else got some? Shane has got some too. Good. Yeah, let's start with 8.3. Let's do that. So anybody in 8.3? I see the earliest one posted right now is number 9. Anybody else got one? Questions for me? Anything? Okay, let's do it then. Okay, number 9. Ugh. All right, well, we could use, I'm just debating, the reduction formula. Do you know what I'm talking about? Did you try the reduction formula, Maribel? And did it not work, or? Well, I'm double backing in my notes so I can find 8.3. Oh, it was a ways back there. Aha, I found it. So I'm wondering, because it's tangent cubed, I'm wondering if we can use this guy right here, the reduction formula for tangent to a power. What do you think? Seem reasonable? Let's try it. All right, so let's see here. Tangent, tangent cubed, oh, shish kebab. 8.3 number, this is number 9, right? All right. Okay, so we want the integral of tangent cubed of x dx. Okay. So, and by the way, I didn't tell you at the time. These don't really count, but I forgot to say this in the notes. Let me tell you guys now. Everybody get out your packets of doom. Do you know the pink ones, the super big integration tables? I'm almost positive the reduction formulas are in there. So you don't really have to memorize them. The reduction formulas don't really count as, yeah. It's right here. So at the time when we first did this, we didn't know about the big table of doom with the 121 integrals, but it's right there. And that one does not count as like using the big table. So don't stress. If I say you can use reduction formulas, then they're right here. All the reduction formulas are in it looks like the last page of the pink sheet. So make sure you have that out, because nobody wants to memorize that. Well, I mean, I shouldn't say that. Maybe you want to memorize it, but I don't want to memorize it. All right, so tangent to the third power of x would be tangent to the, okay, so n for us is 3, so it'll be 2 tangent squared of x over 3 minus 1. So it'll be tangent squared x over 2 plus or minus, and then integral tangent to the n minus 1. So the integral of tangent of x dx. Like that. Oops, sorry, that's off screen. Hold on, give me 1 second. This was zoomed in for the sake of making lecture videos, but it's not really going to help me right now. There we go, got it. All right, so is that one of the answers? No? Okay, then we'll have to keep going. So the integral of tangent, that's on the front page that's in the quick sheet. So this is tangent squared x over 2 minus natural log of the absolute value of secant of x, which I think is, well, it's one of them. Mirabelle, you better?
Yeah, at the time I was doing this, I just couldn't figure it out. That makes a lot more sense.
Yep, don't be afraid to use those reduction formulas, especially for the multiple choice ones. I love the reduction formulas. It makes things easier on me. All right, so good. I see 2 people want number 10. All right, so number 10 must be throwing people. Oh, I can see why. All right. Everybody got number 9? We okay? Cool with 9? See, no takers. Thank you, Lindsay. Thank you, Emma. See, you guys are getting on the ball. You know. All right, we're good? All right, so that one's that. Let's switch to 10, since that seems to be more, work involved. And you guys are gonna have to answer some questions. Ooh, this will be exciting. Oh, I can tell you why you don't like 10. All right, so this is number 10. And again, we're still in 8-3. We haven't moved. All right, so hold on, I'm looking at it. It's sine squared x cosine squared x dx. Okay. So what you gonna try? Hold on. Give me a second. I'm gonna go find that method page, which is in that same section for 8-3. 8-3 is deceptive. 8-3 doesn't seem like it's gonna be that difficult. And then you get into it, and 8-3 is actually pain. Have you noticed that? 8-3 is the worst. All right, so I actually disagree with them here. So it's both even, but I have no desire to use the half angle identities, and I think I can get out of it. But you guys are welcome to if you want to try. But since m and n are both even, right? This is 8-3. This is that for that first method we learned for powers of products of sine and cosine. I am going to do something rather sneaky. I'm going to rewrite this as the sine of x times the cosine of x. And then I'm going to think to myself, you know, to be fair, you guys can use the half angle identities if you want. So sine squared x is, 1/2 the sine of x over 2, something like that. It's the, hold on, it's the trig identity stuff. You're welcome to, but I'm going to find a different identity because I think there's another one that can help me out with this particular. All right. On your trig sheet, you have all your lovely identities. See, there's sine squared. So if you want to use half angle, there you go. Sine squared theta is 1/2 1 minus cosine theta. Cosine squared theta is 1/2 1 plus cosine theta. So you can substitute those in, knock yourself out, right, if you so desire. Anybody really want me to do that way rather than the way I'm about to do? Because I mean, I can do it if you want. The way I'm about to do is sneaky because I'm going to bypass all of it with that one right there. See, sine of 2 theta is 2 sine of theta cosine of theta. See it? So I'm going to kind of sneak my way out of it a little bit. All right, which one do you guys want? Half angle or double angle? We'll be a democracy. What do you want to do? What did you try to do? Did you try to use half or did you try to use double? Or did you not try it at all? You should just stare at it.
I tried using the half angle.
Yeah, it'll get you some yucky stuff in there. Anybody else? Do you want to try half angle? Amna, are you voting for half angle? Oh, you guys are killing me, making me do half angles.
I did, and I got a right answer, I guess, because I checked it.
Ooh, you checked it with Desmos?
Yeah. No, not that one. Yeah.
Oh, with like a computer algebra system or something. Yeah. Good, cool. Well, you could do that. Do you guys want to see both? Is that where I'm hearing? Want me to do both ways just to make your life difficult? Okay. All right. So I'll do both. You guys are killing me. All right. So this is equal to the integral. Okay. Wait. Do you guys remember seeing the identity? The identity for the double angle is that the sine of 2 theta is equal to 2 sine theta cosine theta. So then that means that sine theta cosine theta is 1/2 sine of 2 theta. So that's what I'm going to use right there. So I'm going to take the integral of 1/2 sine of 2 theta squared. Oh, theta, x. Sorry, I switched my variables for no good reason there. All right, x dx. There we go. So then, let me think. We could distribute. So that's 1/4 integral sine squared of 2x dx. And then sine squared, we could use the reduction formula for that we just had. I've already lost my reduction formulas again. Shoot, where'd they go? But you could use that reduction formula to do sine squared, or I don't know, a variety of things. So it'd be this one right here, right? So it'd be negative sine, right, times cosine, and it'd be all of 2x over 2, like that. So I feel like so I gotta find that identity. There it is. Negative sine of, and now it'd be 2x for me. Cosine of 2x over 2. Yeah, over 2 plus, and then 2 over, actually, hold on. So there's got to be a du figured out in here somewhere. I mean, I'm going to go find a real official reduction formula out of the pink sheet. There it is. I thought so. Because if we're going to use u, which we are using, it'd be that. So it'd be negative 1 over 2. Sine, yep, right there. So sine to the 1 times cosine. So it'd be sine cosine plus, I guess I'm doing it right. And then 1 over 2 sine to the 0. And sine to the 0 is just 1, right? So it'd be like that. And then, shoot, 1/2. Where was it? Integral of u, integral of nothing, because it'd be sine to the 0, and sine to the 0 cancels. A question for me, hun? Yes, no?
No, all good.
I know I'm wrong here. There's something, oh, I know. It's because this is of 2x, right? So don't I need a 1 over u in front of all this? Yeah, because like, don't I need like, because u is equal to 2x, then du would be equal to 2 dx, right? So don't I need a half du? Right? So wouldn't I have to have this be an 1/8 instead of a 1/4? Is that making sense to everybody? Because it's 2x, it's not just x, right? See if I'm going crazy. And then, well, I mean, I may be, but I'll pull the half out. So it's 1/16, and this is negative sine of 2x, cosine of 2x. And then this is, let's see, well, the integral of that would be u. I'll just throw a c at the end. And then you just put back in what u was, and you're done, right? So it's 2x. Now, that said, when I do it this way, I might be getting a slightly different answer than, say, what you did when you did it with 2x. There we go. If you'd use half angles, they might look different, but then with trig identities, they are the same. I don't know if you ended up with the same one. So Amna, you did the half angle. Did you end up with it looking like that, or did it look different than that?
Not exactly. I got 1/8. Like, yeah, it was different.
Okay. All right. Well, they might look different, but be the same. I can, because this one is 2. So was it 1/8 and then like sine of 4x or something like that?
1/8 and x minus 1/4 sine 4x plus c.
X minus 1/4 sine x plus c. Interesting. Interesting. So I bet you they are the same. I'd have to fiddle around with them, but I think I can manage it. So that's fine. That is correct if you want it. But I can try to do it with half angles and see if I get the same thing you did. So here, don't you want me to try? All right. So with half angles, geez, I don't know if I can do it on one. You know what? I'm gonna grab a different board. So I'm gonna leave my double angle that way. I'm gonna try it again and see if I can lead it that way. All right. Oh, let's see, integral of sine squared x cosine squared x dx. Okay, so if you're gonna do half angles, I never remember those stupid formulas off the top of my head. They're the worst. All right, so come here, trig identities, there you are. Found them. Okay, half angle. So it'd be 1/2 1 minus cosine of 2x and 1/2 1 plus cosine of 2x. So you'd be like 1/2 1 minus cosine of 2x, and then another 1/2 1 plus cosine of 2x. I mean, technically, this is the way they tell you to do it. So, because in the method, they have you using half angle identities. All right, so a half times a half is a fourth. And then I'm going to FOIL this. It's 1 minus cosine plus cosine cancels. And you're left with minus cosine squared of 2x dx. Right, I'm just foiling. Everybody cool? I should have made you guys FOIL. Next time, I'll get you. Okay, and then you integrate it. You can integrate this one. This one you could use a reduction formula. I mean, it's kind of the same problem we just ran into on the other ways. You know what? I'm just not going to finish it. I'll just leave it for you guys. But you can integrate this one. I mean, this is just there. That's x, right? So, and then minus the integral of cosine squared of 2x. And you can tackle cosine squared of 2x a couple ways. So you can tackle it with the reduction formula for cosine squared. There actually is a formula for cosine squared, I think, somewhere in the big table someplace. There's also another identity if you wanted to muck around with that. You could use the half angle identity again and make this into here 1/4 x minus integral. Let's see, it'd be 1/2 1 plus cosine of 4x. Like that. And there you go. Now you're cooking. Everybody better? At least have a plan? Martin, what about you? Are you better on that one too? So Stacey, you asked it. Shane is better. Shane is thumbs upping me. I didn't finish it, obviously, but we're really close right there. You let u be 4x and away you go. We good? Thanks, Martin. Everybody else okay? Out of curiosity, let's have a vote in the chat. Which did you like better, double angle or half angle? Which way makes you happier? I got 1 vote for double, 1 vote for half. So far it's even. Come on. I should make a poll. It's interesting. It's pretty split. That's fine. So do it whichever way you like. So Emma likes half, Shayna likes double. Jessica has no opinion yet, I think. Yeah, Jessica, come on, you got to vote. Interesting. So it's really evenly split. That's totally cool. So use whichever way makes you happier. I will warn you, the double angle people, I like it too. However, see, Daniel, that's the right answer. They both are not fun. But see, the trouble is, guys, that the double angle one's kind of a trick. Like you're not able to use the double angle one nearly as often as you are able to use the half angle one. I'm sorry to say. Half angles are not my favorites either. So cool. All right, we're good. All right, so that's the end of that one. And now you guys have chatted so much that I got to go back up and find the questions. All right, so 8-3, we got 9 and 10 done. And then I see 11 and 12. Okay, 11B, Shayna. Oh, yeah, I can see why you don't like that. All right, so hold on. Okay. Boy, this is not fun. All right, so we are integrating. This is 8-3, number 11B. Okay, so we are integrating -5, what is it, cosecant to the 4th of x over cotangent square root of x dx. All right, so thoughts? Any ideas? Any good first steps?
Convert them like cotangent, cos over sine, cosecant 1 over sine.
Yeah, I think it's a good idea, Daniel. So making everything into sines and cosines, you guys hear what he's saying? Because then maybe some stuff will cancel and make the problem a little easier. That would be good. That would be helpful. All right, so let me see here. The derivative of cotangent is cosecant squared, right? Just something to keep in mind, because that could be useful to us later. All right, but I'm liking his idea. Hopefully you guys are too. All right, cosecant. Cosecant is, somebody other than Daniel, cosecant is? Give me an identity, something that'll be useful. Oops, I see, sorry. I've scrolled up and now I gotta go scroll back down. Yeah, cosecant is, you're on the right, no, Connor, you got cotangent. So cotangent here is cosine over sine. That's cotangent. Cosecant, somebody other than Connor, and other than Daniel. Daniel, you already answered. Oop, we lost somebody. Uh-oh. Hopefully, oh, she's back. Lindsay, you good? Had some internet issues, huh?
Yes, my internet has been terrible today, but that's okay.
Sorry, hon. I'm recording, so if you can always come back and rewatch it later. Whatever you missed. Sorry, girl. All right. Yes, I see it, Jessica. You're right on. So it's 1 over sine to the 4th of x. Good. Okay, so now let's turn this big guy right here into, well, what we're going to do is we're going to take this one, we're going to flip it and multiply, right? So this is the integral of -5, 1 over sine to the 4th. And then it's going to be times sine squared over cosine squared. Ah, everybody good? Anybody got questions? All right, so things cancel. Yay. Woohoo, look at that. Well, we got out of something. I don't know what. All right, so that means that we are now at, oh, and why do I keep putting that there? It's a constant. All right. All right, now, options. So I can see 2 options. I'm not sure the second one will work. So my first option is to do what we just did and use half angle identities. So sine squared is like a half times, was it 1 minus cosine or whatever over 2, cosine of 2x over 2. And then the other one is 1 plus cosine of 2x over 2. Sorry, I was grading really late last night. All right, so I'm wondering about, this is cosecant squared, right? Isn't it still cosecant squared? So this is cosecant squared, and then 1 over cosine. Ugh, that's secant squared. That doesn't help. Boo. So I think we're stuck. I think we're gonna have to use half angle identities down here. Yeah. So let's do, this one is here. Oh, that's a 5, but it didn't look like a 5. And then integral, and then 1 over, okay. Half angle identity is you take 1 for sine, I think it's minus. It's minus cosine, looking at my identities, over 2 like that. And then this is 1 over 1 plus cosine, like that. Everybody good? I just used those stupid identity formulas, the half angle identity formulas. We good? And then 20, right? Because the 2 times 2 makes 4, but it's in the denominator of a denominator. So that really comes up and is in the numerator. And so this is really, this, I have to say it, but again, we actually had a double angle option as well, because sine times cosine squared, right, is a double angle. So again, those of you that like the double angle, you could do that. So you could go this way, or you could go, let me think. It'd be like sine of x cosine of x squared. And then you could muck around with the double angle identity. So you can do the double angle identity or you can do the half angle identity. You again have that option. Half angle identities, this would be -20, because this is 4 right here. And then over 1 minus cosine squared of 2 theta. Like that. Everybody good? So this is another path. Like there, you guys got to pick which path you like, right? So would you rather do the double angle? Would you rather do the half angle? Your choice, right? So then, I know what you're thinking.
I have a
Go ahead.
question.
Oh, go for it.
Why did
Go ahead.
you put theta in instead of x, or do you?
Because I'm just being dumb. I told you I'm tired, Martin.
Oh, okay.
I mean, Martin, I don't know what you're talking about. I see no theta. There we go. Thank you, Martin.
Oh, geez, my eyes must be playing tricks on me.
Whoops. Sorry about that, guys. I'm tired, I tell you. All right, so this is gonna be a fun day. All right, so everybody good there? Sorry about that, Martin. Thank you. So again, choose your path, but your next step is kind of similar for both, right? This one would be, so I know what you're thinking. You're thinking, oh, that doesn't look any better. Like that looks just as bad as the thing I started with. And the answer is it's okay, because there's another identity, a big one that we use a lot that will help us out here. Uh-oh, we lost somebody else now.
Is it the Pythagorean identity?
It is, yeah, you got it. So this is -20, and then this is 1 over sine squared. It's the Pythagorean identity. Ta-da. And so then 1 over sine squared is cosecant squared. And I think we actually have a formula for that, if I'm not mistaken. Oh, cosecant squared, where are you? Yeah, it's in there. It's in your basic formulas. It's number 15. So it's, I'm not even going to finish it. I refuse. You guys can do it. So, I mean, you have to do a little baby u sub, but it's there. And that's where this goes too, because this is a half sine of 2x in here. So this is -5 integral 1 over, and then this is a half sine of 2x, like this, squared. You actually get to the exact same spot in both of them, right? Because a half squared is 4, 5 divided by 1/4 is 20. They literally will get you the same way both ways. And then cosecant squared is in your formula sheet. Everybody good? I didn't finish, but we're almost there. You do a little bit more sub and kind of finish it out. And both paths work. They really do, but double angle was easier again. Sorry, double angle just occasionally, when you can use it, double angle is easier. But this wasn't too bad. I mean, you just had to distribute and then, you know, FOIL it out, and then there you go. I'm going to put away these formulas, otherwise I'm going to lose them. I'll just refer to the reduction formulas. It just occurred to me, you guys have no idea what I'm talking about. So if you have not watched 8.6 yet, or no, 8.7, 8.6, 8.7, 8.7. There's a whole, remember that the pink sheets in your course pack? That's the big integral tables. Most of our integrals are in there anyway, although the quick reference sheet is still pretty useful, to be honest with you. But those reduction formulas from 8.3, they're in there. And feel free to just use them out of there. You're going to get that pink sheet on your test. So don't lose any part of it, because you're going to have that. So those, both your orange packet and your pink packet, are going to be able to be used on that exam. Okay? And reduction formulas are up for grabs. So, but you don't need a reduction formula here. This is actually a quick sheet formula. This is right on the basic sheet. All right, so everybody's good. No more questions on that one. That was 8.3 number 11B. And then I remember somebody had another one. Shane, it was you, 12 and Shayna. I said Shayna, but it didn't sound right. Shayna. 12a and b. So both parts of 12, huh, Shayna? Can't give me a break, huh? It's deceptive, isn't it? 8-3 seems like, oh, it'll be no problem. And 8-3 can be a bear sometimes. It's all these identities everywhere. All right, I'm about to erase. Are we good? I'll wait. I'll wait for thumbs upping. It's a verb. We're good. Jessica, Daniel, you guys okay? CJ, you good? I just have these great fears that CJ's sitting there like writing as fast as he can and I'm about to erase on him or something. So hopefully you're okay. You good? Okay, good. All right, so off we go into the realm of number 12. By the way, how'd you guys like trig substitution? Huh? Seeing no thumbs up, I'm assuming that's that says you didn't like it at all. Oh man, I love trig sub, but it's a little mind bendy your first time. You're like, wait, I can just substitute anything I want, and the answer is sure. Great. The problem is most things you would substitute won't be useful for you. Trig sub actually is useful. All right, so let me see. 8-3. This will be 12a. What do we got? Integral from, oh, I can't read that writing. From negative pi over 4 to pi over 4. Of 7. Can I just put the 7 out? Is that right? And then square root 1 plus cosine of 4x. And I think that's looking familiar. Oh, trig identities. You should have your book open to the trig identity page. Yeah. It's in there. Do you see it? There's one that's going to be pretty useful for us. Well, I'm going to scroll down, see if somebody can get it. Amazingly enough, it's not Pythagorean this time. Pythagorean's not so useful. What are we looking at? We're looking at 1 plus cosine. Yeah, because it's not squared, right? But it could be. Do you see it yet? It's not going to be exactly the same, but it looks similar to what we've got. Look at your cosine squared theta half angle identity. Everybody see that one? Doesn't it look, especially over on that right side, forget about the half for a second. The half is just going to be a constant. We'll deal with that. But doesn't that look a lot like what we've got? So it's 1 plus cosine of 4x for us, 2 theta for the identity. But doesn't that look a lot like what we have? Yeah. So let's take a moment and play with that identity, shall we? I'm just going to do it over here on the side somewhere. All right. So the half angle identity says that cosine squared of theta is equal to 1/2 times 1 plus cosine of 2 theta. Sorry, I'm working in this terrible marker. Okay, so 1 plus cosine of 2 theta. I want 4x, right? So I'm going to put in 4x where there was 2 theta. And that means I'm going to have 2x over here because this is half of that angle. That's why it's called a half angle identity. It used to confuse the crap out of me when I was a student. I mean, like, why do they call it a half angle? And it's half because this one over here is half. So it's cosine squared of an angle that is half as big as that angle. Sorry, my cosine got weird there. It looks like a blob, but it's cosine. Everybody good there? See it? So then this is the part I want. So to get rid of the half, I just multiply by 2. So 2 cosine squared of 2x is equal to 1 plus cosine of 4x. This is it. So I'm going to use that underneath my square root. So in my square root, it's going to be from negative pi over 4 to pi over 4, square root, and then I'm going to plug in cosine squared of 2x. I've cut my angle in half from what it was. hence the half angle identity. So I started off with an angle of 4x, and now I have an angle of 2x. Fun, huh? These sections use half angle all the flipping time. They really just do. All right, so why is that useful? Well, because I have a square root. A square root and a square, undo each other. And I think at that point I'm done. My work here is finished because I think you know what to do from there. So negative pi over 4 to pi over 4. And lo and behold, we're taking the integral of cosine. And I think we all know how to do that. So I'm not going to finish. I did the hard part. It was the half angle identity. Tempting to use the double, but it's not. It's the half one. Actually, I don't know if the double one might have been useful. And you know what? We probably could have made the double one work. I take it back. We could have used a double angle also. So Connor, you are right. We could have used double. We could have used that double right there. The cosine of 2 theta is equal to 2 cosine squared minus 1, because then the ones would have canceled. You'd end up in the same boat. You'll end up here. It'll just take you a different path to get there. So double angle also would work. So either one. Ta-da. Go ahead.
Should there be a 2 with the cosine squared 2x?
Oh, yes, there should, I think. Wasn't there a square root of 2? Sorry. Thank you, hon. It's a 2 there. So it's really like square root of 2 out here because it's a constant. So we can just yank it out. Yeah. Okay. Sorry about that. Thank you. See, everybody's catching my mistakes today. It's good. Now, I didn't finish, but I think you guys can all finish. And you're actually submitting them, so just leave it exact. I mean, if you want a decimal approximation after that, that's fine. So, Good. Thank you, guys. Give me a thumbs up and let me know you're done. And again, hey, Connor, if you want to go the other way and do a double angle, fine. Knock yourself out. You should get here. You'll get to the same place I got. It'll just take you like a different path there. It'll work, though. All right, cool. We're good there. So I see a lot of thumbs upping. So, and honestly, you can finish it on your own. You know, you got the hard part done. I've lost my whoopee. Oh, here it is. I don't know what to call this thing. My eraser. I know, but eraser's a boring name. I want, it looks like a tribble. It looks like a creature. So it deserves a name. All right. Okay, so this is 8.3 number 12b. So let's see, we're integrating, oh crap, 0 to the square root of pi over 2? Yes, it is. All right, square root of pi over 2, sure. Of the 7x sine cubed of x squared dx. Okay, the first step should be obvious to everybody.
U sub.
Yes, U sub. That's a good question. I'm reading Amna's question. Will it work with a reduction formula? I don't think you're going to need it. It would, but I don't think you're going to need it. Yeah, go. I mean, you can use a reduction formula. Let me get to the U sub first, and then hold on. Hold that thought, girl. All right, so U is x squared. I'm sorry to say I wasn't looking up, so I don't know who said it, but whoever that was, you were right. And then du would be 2x dx. And so that's great. We want the x. We want the dx. We don't really want the 2. So we're going to do a half du is equal to x dx. Okay, so think. Can't use those numbers. I'll be back for you. But I can say 7 times and then sine cubed of u. And then I can say a half du. Now, the one problem is that the numbers that existed were for x. And now we want them for u. So if x is equal to 0, u is equal to 0 squared, which is 0. So that bottom number is the same, actually. Fine. When x is equal to the square root of pi over 2, u is just pi over 2 because it's that squared. So that's going to change that to pi over 2, which let's face it, we would all rather deal with pi over 2 than the square root of pi over 2. Blech. Nobody wants that. And then I think this is where Amna's asking, can you use a reduction formula? Yep. Yes, you could. You could also do the little trick of breaking off a sine squared using the, here, hold on. It's up to you. So you have 7/2 integral from 0 to pi over 2 sine cubed of u du, like that. And so at this point, you can either do a reduction formula or you can do the thing where I'll present to you two paths and let you guys pick what you want to do. So you can go one, you know how this is sine squared u times sine of u? So that's really 1 minus cosine squared of u times sine of u. And you can use a second substitution. So that's one path. Here, the paths break here. So you can go and kind of go this way. That's the method that they show you when they're like, okay, sine was odd power and cosine's an even power, and you break off a sine and use 1 minus cosine, and then you'll have your u, which is cosine, and your du, which is sine, and this is 1 minus, right? And you do that whole thing, right? You do a second u. So you go like u number 2 is cosine, and then du is sine. du1, because this is now u1. So you'd have to do it that way. So these are u1s now, that kind of thing. You could do that, and that's fine. That would work. The other option is reduction formula, because it didn't say you couldn't use them, right? So you could use a reduction formula instead. Both of those can work. So the reduction formula, I'd have to pull it out. It's on the big pink packet of integrals. It's on the last page. It's this formula bit right here. So you could do that instead. Either way. Is that good? Does that help you guys out? I didn't finish, but
If you do,
go ahead.
if you do a second u sub, don't you have to change the limits of integration again?
Yes, you would. However, they'd be even easier because the cosine of 0 is 1 and the cosine of pi over 2 is 0. So to go from 1 to 0. So it'll be like 7/2. The integral will change from 1 until 0, right? And then it'll be 1 minus u squared du. There might be a fraction in there that I'm forgetting, but honestly, we should probably just change the letter, to be perfectly real with you. I mean, because u gets a little confusing if you're using it twice. So what you could do, just to kind of clear things up, pick another letter. What do you guys want? V, W. Can't pick X, and you can't pick U. So pick another letter. Z. Somebody pick a letter. I've got my orange marker waiting. V, there you go. So dV, then that's probably a good move, Connor. So not V, just V. V is cosine. And then dV is sine. Oh, is it negative? Yeah, it's negative, right? I knew I was missing something. It's negative sine of u du. So we'll just stick a negative in front of this whole thing. So this will be dV and this will be V. Like that. Oh, good for news. It just occurred to me. So if you didn't like the fact that it went from 1 to 0, that just makes your algebra brain cringe, which actually happened to you guys a couple times on your exam, by the way. You actually were supposed to go from like 0 to a negative for that work function for Hooke's law for the spring. And some of you just would not do it and went the other way and you made your work negative. A few of you did that. It's you know, because it hurts, you know, because you get so used to always having the lower number be lower, which of course is not always the case. You learn those properties in Calc 1, but you forget them in Calc 2. So if you don't like that it goes from 1 to 0, you can flip them and then you'll lose the negative in front. So then it'd be 7/2 from 0 to 1, like that. Right? Do you remember that property of integrals, that if you flip the limits of integration, it flips the sign, right? Which is why a couple of you ended up with negative work when you shouldn't have. And it's because your signs were, your symbols, things were flipped. It happens. Everybody better? And then Amna, if you want to use the reduction formula instead, fine, right? It'll get you the same answer. Just be careful with those numbers, right? It'll work. And you can always check yourself. The good news is that this is a definite integral, and definite integrals check in Desmos hell. You know, you can check them all sorts of ways. The sun is shining. It's so pretty outside. All right. All good. Everybody better? I didn't show the reduction formula, but it's a formula. You just plug through it. The only thing you'll have to do is keep your limits of integration. So there'll be 0 and pi over 2 through the whole formula, because you'll be doing it for you. You never go back. See what I mean? Like, so I know a few of you have run into troubles with this, but we're not going to the back substitution. We never go back to x. I never use the square root of pi over 2 ever once I figured this out, right? So with a reduction formula, you'll be ending up with 0 and pi over 2's over here, right? You'll have like that first bit of your formula. It'll be, here, I can write it down. It'll be like -1 over n, what was n? 2? 3. -1 over 3 sine squared of u, cosine of u. And you're going to take that from 0 to pi over 2. Like you're going to do that bit and then minus or plus, and then you keep going and blah, 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 blah. And that next integral is also from 0 to pi over 2, yada, yada, yada. Like it keeps going like that. Or if you want, you can wait until you've done the whole thing and then put 0 and pi over 2 in, right? Which is what I would do probably. Just keep the 0 and pi over 2's until the end. But it should work out. All right, so 8.3 I think is done. Hearing no takers, I think we're finished, because those were the last questions on 8.3 anyway, right? Was there any 8.4 stuff? I thought I saw somebody had an 8.4 question. Oh, 5 and 6. Okay. You guys need this anymore? Can I erase? We're good? Yay. Martin, Amna, Jessica, Christian, you guys okay? Ready for me to go? Cool. All right, we're good. All right, so the thing about trig substitution and is it's so hard to remember which one to use when. So you got to try to like memorize it just for the test. You know, it doesn't have to be long-term memorized or anything. Technically, there are ways you could figure it out from the packet, from the big pink packet of integrals. You can kind of tell by looking at the style, like which one's going to go with which. But for example, x squared plus a squared is the easiest one to remember because arctangent. Yeah. So if we look at these styles, right? If it's 1 minus u squared, that's sine, right? So if it's something squared minus u squared, that's sine. If it's something squared plus u squared, that's tangent. And if it's something squared minus, x squared or u squared minus something squared, then that's arcsecant. So you can sort of see them in here. It's just that the ones for us won't always be that. They'll usually be a's. Yeah, it's easier to see right here. So the trig substitutions are right here. It's one of the reasons you don't need to get it on your formula sheet elsewhere. So by memorizing. You just have to remember that, hey, if it's that form, it goes with sine. If it's that form, it goes with tangent. And if it's that form, it goes with secant. There are your substitutions, pre-memorized. Yeah. And since you're getting this sheet, hooray. So, all right, so let's look at, which one is this one? 4? Is that what it was? I think it was it 4 or 5? I can't remember. All right, so I'll go back up and see what it was. It was 5 and 6. Okay, so 5. What we got here? 9 minus 4x squared. Okay, so, oh, sorry. Oh my goodness. So it's something squared minus u squared. So 9 minus. So obviously it's going to be in this style. That's why all 3 of them have signs involved, right? Okay, so we know we're in the right zone. So it's this one. The question is, which one of the 3 is it? Okay, so it is sine of theta is equal to x over a, but we have 4x. Sneaky. Okay, so let me rewrite this. So dx over square root of 9 minus 4x squared. That's some, let me think. That's the integral of 3 squared minus 2x squared. Yeah, you with me? Okay, so then that's u, right? So I could say this is the integral of, if u is 2x, du is 2dx, right? So then a half du is equal to dx. So I don't think this is the only way I could explain this, but maybe this will be comfortable. Minus, and then this would be u squared. And then there'd be a half du. Okay. So then, and I know I need to find x. I'll get there. I'm just thinking about this. Okay, so let's think. If I'm going to do a trig substitution, the trig substitution would be that the sine of theta is u over a for us. So we would be saying, hey, the sine of theta is u over a, which is 3. Okay, so then that means that the sine of theta is, keep in mind what u was. U was 2x. Because the multiple choice question is basically wanting to know what x is. And then you solve this for x. And you've got it. So I didn't finish it, but I'm 1 step away. Is that better for whoever that was? I don't remember who it was. And everybody else, is that making sense? Solve it for x, and that'll give you what to choose. Oh, go ahead, Mirabelle.
Clarify with your work, is there supposed to be a square root over the 3 squared minus 2x
Oh, yeah.
squared?
Sorry. Yes, sorry. Right. Because I'm not actually going to do it. So all I was caring about was the form. But yes, you're right, Mirabelle. Thank you. Yeah, technically, those trig substitutions can be for u squared. We don't do them as often, but it's possible. So makes them sneakier, more difficult. All right, so that's 5. Oh, I gotta go find 6. What was 6? I've lost my sheet. Oh, I know what you have to do for 6. Do you know what you have to do for 6? It's more of the same, but 6 needs completing the square. Because hello, trinomial just sitting there by himself. So it's dx over square root of x squared plus 2x. You know what? I'm just going to start prepping that completing the square right now. So I need to put in a number that would turn these first three terms into a perfect square. Anybody know what number? I'll wait for you to type it. Or say it.
1.
Mm-hmm. Because you take b, which is 2, you divide it by 2, and you square it. Right? So this turns into a perfect square. So this is the integral of dx over square root, and then it's x plus 1 squared plus 9. So it's going to be an arctangent. I can tell you right now. So there's no way in hell b is correct. It's got to have to be a, because that's u squared plus a squared, right? If it's u squared plus a squared, that's arctangent. And it's kind of the same boat we were running into the previous problem, right? U is x plus 1. Du would be dx, so that's really easy. So this is the integral of u squared plus 3 squared. And then du on the top. So then we would use the arctangent thing. So it'd be u is equal to, or tangent of theta is equal to u over 3. So then you know that u is x plus 1. And you solve it for x and you'll have your answer. Actually, I don't even think you have to solve for x for this particular one. I think it'll be obvious which one it is. Everybody good? Yeah, so those two are both the same kind of thing. They weren't as straightforward in their u sub, or in the trig sub, because you have to use like a u sub first to kind of get there. So they're a little weird. Shayna's thumbs upping me. Thank you, Shayna. I appreciate that. All right, so that's 8-4. Anything else on 8-4? You guys make me nervous. Eight, four. Come on. So trig sub was easy for you guys? You had no problems with trig sub and it was going great? More power to you if it was, hey.
Can you just start, I think it's 8D.
8D.
I think it's just, the E is throwing me off and I
Oh, okay. Good. No, good one. Hold on, I just got to find it. But yes, I can. I've lost my 8-4 worksheet. Where the heck did it go? All right, I've got 8-3. Oh, there it is. It was at the back. Hold on, I got it. 8D. No worries. Yeah, is it one with like e to the x in it or something? E to the 2x maybe? Oh,
yeah, e to the 8x.
No, got it. All right, I'm going to erase. Everybody good for this one? I think this was 6. Sorry, I forgot to number this one. It's 6. All right. That's a good one to ask, actually, because that's 8D. All right. Did you guys hear that? That was my dog. She just went shake, 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 shake right near me. Just flapped her ears. Hi, Mina. Hi, baby. Yes, you're very cute. Okay, so hold on, let me write this down. Here it is. So the integral of dx over square root e to the 8x minus 9, that one. And it's going to actually have another u sub. It's going to be kind of what we've been doing. So I may go through more of this one, actually. This is a good one. Good call. So u would be, u is e to the 4x. Let me put it that way. So if I rewrite this, let me just think about this. I want dx, I want something squared minus 3 squared, right? That something is going to have to be e to the 4x. Because e to the 4x squared would be e to the 8x. And there's my u, right? not really like u as in like I'm going to do a full u sub, but I'm just thinking about how these things work, right? So that means that, and of course, u squared minus a number squared means it's secant, your favorite and my favorite. So this is going to be the substitution we're going to make.
Miss Tucky,
Yeah, go.
I know this might be stupid, but why isn't it 8 to the e x squared? Like when it's the squared?
8 to the e x squared. Hold on, you lost me.
Because you put e to the 4x in for u, and it's squared. So
Yeah.
wouldn't it be e to the 8x squared, right? Or no?
Oh, wait. No, hold on. No, it isn't. Not gonna, it's multiplied. Oh, I see. No. It took me a second. I get what you're asking. Hold on. Can I just, I got to fix it up here. Is that okay? So if I go, can I just give you another example? So if you learn x to the a to the b is x to the a times b, right? So when you have e to the, I'll just make one up, 3x to the 5, that's e to the 3x times 5, which is e to the 15x. Oops, sorry, that was a 5. My 5 got weird there. It's multiplied, but not raised to the. I know it seems it's weird. It's because this power. So you're taking e to the 4x and raising it to the 2. It doesn't square the x. It actually squares the e to the 4x. It squares the base. It doesn't square the power. You just multiply the powers. Good question. Is that better? Is that making sense? It's because of this property of powers right here.
Yep, thank you.
You're welcome. So everybody better now? Okay, so then my trig sub. So it's a secant one. So it's the secant of theta would be equal to my u divided by my 3. I'm just seeing what I wrote. So it's e to the 4x over 3, like that. That's going to be the substitution I'm going to make. Which, by the way, means cosine of theta is the reverse, but whatever. All right, so remember how secant, here, I'll just write it. So cosine of theta is 3 over e to the 4x. I don't know which way you guys prefer. I mean, they mean the same thing. So when you have theta over here, cosine is adjacent over hypotenuse. Secant is hypotenuse over adjacent, right? So the hypotenuse is here. The adjacent side is here. And then you can use Pythagorean theorem to find this, right? So 3 squared plus, I don't know, I'll call it b. B squared is equal to e to the 4x, 4x squared. So that would be b squared is equal to e to the 8x minus 9. So b is the square root of e to the 8x minus 9. Hey, that looks familiar. Right? All right, what else do we need? Cosine of theta, we've got theta, d theta, d. I'm just trying to think of all the stuff we need. There it is. All right, so I've got my theta, secant theta. Secant theta is right there. I know that u, which is e to the 4x, would be equal to 3 secant theta. I know that, let me think, cosine of theta I've got right there. E to the 4x is that. I know that I could find x because I could take the log of both sides and then that would bring the 4x down. So 4x would be the logarithm of 3 secant of theta, and then I divide by 4. Like that. I mean, if I need to. Dx would be the derivative of that, which would be 1/4, and then you do 1 over 3 secant theta times the derivative of the secant, which is secant tangent. And then the 3 secants cancel. And you're left with tangent theta over 4. Remember, all of this is on the left. Like you figure out all this crap. Like don't wander it around the page. Like don't like make it do loop-de-loops. Like all of your like trig sub work is over here. And then over on the right, we'll actually do our integration work, right? So I've got my x, I've got my dx. Well, anything else I need? Theta. Theta is the arc secant of e to the 4x over 3. I don't know if I need theta, but I mean, I can grab it if I need it. Theta would be, if I solve this, if I divide that by 3, so the secant of theta would be e to the 4x over 3. So theta is the arc secant of e to the 4x over 3. Hopefully I have nothing else to do because I am out of room for substitution, but there you have it. All right, so I found my x right there. I found my dx right here. I found my theta right there. Those 3 big ones. Uh-oh, we lost somebody. Somebody's just dead too. I think it was Daniel we lost. He probably has bad internet. I'm going to assume he's not like, I'm done with this. There he is. Everybody good? I assume you're writing down. Daniel, I was worried you were just secant to theta is dead to me. Just leaving. I assume it's internet problems. All right, so we can go substitute finally, right? We just did all the prep work, and it's a lot of prep work. Hopefully you guys are writing fast and furious here. So I'll just go over it one more time. Secant of theta is u over 3. U is e to the 4x. So therefore, it's the secant of theta is e to the 4x over 3, aka the cosine of theta is 3 over e to the 4x. So then I build my triangle, right? I've got my stuff in there. And honestly, anything I want, I can build out of that triangle, including that e to the 4x is 3 secant of theta, which means this is true, right? This part right here. I don't want to box it. It's not an answer, but it's important. And then dx is further down. Dx is the derivative, which is right here. And then I'm running out of colors. What else have I got? A weird purple that won't really look any different. Ooh, we've got green. And then theta is right here. I think actually we don't need theta, but I'm not 100% sure, so I grabbed it. Everybody got all of that? I did my derivatives pretty fast. I should have made you guys do them. God bless it. I just get so excited about doing derivatives. I can't help myself. they're so you just do them, you know? So 1 over multiplied by the power, and then cancel. That's easy. And this is a little trigonometry right here. Thank you, Shannon, for giving me the thumbs up. I spotted it. It always cracks me up because in trig, you know, they kind of blow past arc secants, like, oh, you know, you'll never need that. And the answer is like, yes, you do. You need everything in Calc 2, everything. Like every pre-calc and trig trick you ever learned, bring it on. We're going to use them. All right, so everybody okay so far? Can I move to the other side? Because once I go up, you won't be able to see what I wrote here. Good. Shane, I know you already gave me a thumbs up. You don't have to do it again. I appreciate it. Just let me know when you're ready. Ben, Mirabelle, Martin, are you guys okay? Oh, Daniel's applauding me. Thank you, Daniel. All right, cool. I think we're good. All right, so then let's go back over here. Whoa, to the top. I gotta move that. And then let's do some substitution. Like, let's make it work. So somebody's calling me on my phone. Go away. Okay. All right, so this is the integral of, all right, square root. And I think it's just going to be easier if I use one that I haven't used before, but I'm just going to use this. See that? Because, I mean, why bother with what x is when I can just do e to the 4x, right? Like, I could use x, but wouldn't it just get me where I, you see what I'm saying? So let's just use that and say, hey, that's 3 secant of theta. Call it a day, rather than having to muck around with what x would be. Because, I mean, I can put in x, I can substitute it. And when I put it in, oh, sorry. But when I substitute in x, it's the natural log and blah, 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 blah. It's going to work out to be the same thing. Things are going to cancel. So why not just skip the middleman since I know what e to the 4x is and put in 3 secant theta. And then it's minus 3 squared. Like that part hasn't changed. Minus 9 if you want. Actually, I will say minus 9. I take it back. I'm just going to make it 9. There we go. I needed the 3 squared, so I knew it was, I knew the 3 over here, but other than that, I don't need it. And then the dx, I found down below, it's tangent of theta over 4. D theta. Oh, crap. Oh, you guys didn't catch me. There's a typo right down there. My bad. Right, you got to have a d theta in there. You have to have a differential. All right, so sorry about that. Fix it. Because you need that d theta. You need to have an integral. Your integral has to have a differential. Let's put it that way. You have to have a variable that you're integrating with respect to. So put your d theta in right there because I need it right up here. I knew I was in trouble when I got up here. I'm like, wait a second. I have no differential. Like, what am I integrating with respect to? Because the differential ends the integral symbol. Everybody's good. Okay, so now 1/4 comes out. Why not? And actually, I'm going to do something rather clever in here. This is underneath the square root. Oh, crap. There's a secant squared. So it's secant squared theta minus 1. See what I did there? I did 2 algebra steps at once because I got skills. Actually, I did 3. I am so good. I pulled the 1/4 out. I did 3 squared in my head. You know, not everybody can do that. 3 squared is 9, and I factored a 9 out. Right? Why did I do that? Well, because the square root of 9 is 3. So then I can say, well, that's 1/12. Yes, I could have done another step, but I didn't. So I just did the 12. Everybody good with the 12? Square root of 9 is 3. 3 times 4 is 12. Now, underneath that square root, anything shouting out to anybody in your head?
Tan squared.
Yes. Did we hear him? Tan squared. Pythagorean identity. Yeah. So this is 1/12 integral 1 over the square root of tan squared theta. I believe my work here is finished. I will let you finish this out yourself. I did the heavy lifting, and there's a lot of heavy lifting, but I did it. So you guys can finish it out. Sorry. Apologize. It's gonna be a long day. All right. Good there for 8-4. Anything else in 8-4? That's actually one of the more difficult ones. So it was right. I think it was Emma. Emma, were you asking this one, honey?
Yeah.
Good one to ask, because I think it has the trickiest one on there, as I recall. It's the whole like secant equals e to the 4x thing. That's weird. Most of the rest are not as difficult. I will warn you guys on C, you have to complete the square. Did everybody catch that for letter C for that same problem? It's on page 4, I think. Just a little warning to you. Make a little note to yourself at the top of the page. You need to complete the square. I've done a lot, so you can do it now. And actually, hopefully you were taking notes. See, this is why it pays. So if ever you're sitting there and like, I don't need to take notes on this one because it's a multiple choice question. The multiple choice question that I answered for, what was it, number 6, would help you with C, right? So if you took careful notes for that, that would help you out with C. That's the way you got to be thinking, right? Anything else for 8-4? If not, then I can pause right here and we can start on sample exam stuff right now. I'll just stop the recording and we can go there to questions people have on that. Although I need my answers. I don't remember what I asked. Ugh. It would help if I could find a sample exam. Oh, there it is. All right. Anybody else? Oh, 8B, 8B, Connor. I see you, Connor. Hold on. I'm getting it. 8-4, number 8B as in boy. Hold on. Ooh. I don't think it'll be too awful. I think the substitution itself is pretty awful on 8B. All right, everybody got D? Can I move D out? You guys had enough time? I think you're good. All right, 8B. All right, what are we looking at? 8B. So it's the integral of the square root of x squared minus 196 over x dx. Well, again, it's an easier problem in a way than the one we just did, but it's secant, right? When it's something squared minus a number squared, right? That's secant. So, and that's 14 squared for the record. So secant of theta is going to be x over 14. And again, 196 is 14 squared, if you don't remember your times table. All right, so that means, let's think. That is hypotenuse over adjacent is how secant works. So this is theta, then this is x, this is 14. Over here would be b, so 14 squared plus b squared is equal to x squared. So b squared is equal to x squared minus 196. So b is equal to the square root of x squared minus 196. Convenient. Right there. Cosine of theta would be 14 over x. Let's see, x would be equal to 14 secant of theta. Dx, because I'm going to need a dx. One of the reasons I have to find x is because I have to find dx. If I'm going to make the substitution, I need to have a substitution for there. So I need an x and I need a dx. So dx is the derivative of secant, which is secant tangent. So that's 14 secant theta tangent theta. D theta. I'm not going to forget my d theta this time. Anything else? Theta. Well, theta is that angle right there. So theta is the arc cosine. I mean, arc secant of x over 14, or the arc cosine of 14 over x. You know, pick your poison. Whatever. That's an equal sign, by the way. It's not a minus. It's just like whichever way you want to go. It doesn't really make any difference. I don't even know if we need theta, to be perfectly honest. Okay, so let's go substitute. So when I look at this, this is equal to the integral of, okay, in the denominator is x, which is 14 secant of theta. Up here is 14 secant of theta squared minus 196. And then instead of dx, we'll have 14 secant theta tangent theta, d theta. Like that. Oh, sorry, that got all blurry. But do you guys know what that is? I'm sorry. So it's 14 secant theta tangent theta, d theta. Because, okay, these are going to cancel. So that's nice. That's gone. And then in here, I've got 14 squared secant theta. So here, this is the integral of the square root of 196. I'm going to do it again. Secant squared theta minus 1. And that's tangent theta d theta. There's no more denominator. I don't even know why I put that big bar in there because I don't need it. I mean, technically, it's over 1, but irrelevant. So then I'm going to factor this out. So it's 14 integral of square root of secant squared theta minus 1 tangent theta. And so, recommendation, except from Daniel. Daniel, you just led us to the correct answer in the exact same way on a previous problem. Somebody else, what are we going to do? Yes, yes, Jessica, identity. Yes, Pythagorean identity at that. PYT. so make it a Pythagorean identity. So use Pythagorean identity in here. You're going to have 14. So then that gives you this, right? Because it's tangent times tangent. Now I know what you're thinking, like, well, that's no better. But it is. And I wouldn't even use a reduction formula here. Use the Pythagorean again. So use Pythagorean once to get you here, right? Do it again. Use it again right here. Because we don't have an integral for tangent squared, but we do have an integral for secant squared. We know what secant squared is, right? So, and then you guys can do your integral and do your substitution, and from there on you move. You good? It's not done. It's got a few more steps, but I mean, it's getting down to it. Is that better, Connor and CJ? Sorry, I didn't see both of you ask that one. It's not finished, but is that better? Good. So use Pythagorean again, make it secant squared, do integrals, and then kind of clean it up a little bit. Things will cancel a little bit and work out nice. The one thing I will say, remember, you know how you've got a triangle over here? Here's my other hint to you about this problem. If I wanted any of the 6 trig functions of that angle, I could get them. I mean, I already know secant and cosine, so that's easy. But if my integral comes up with something like cotangent, it doesn't, but you know, I could come up with that integral because cotangent would be 14 over this, right? Or sine would be this divided by x, right? So like, I mean, I can come up with any one of the trig identities I want to from that triangle. That's my other hint to you, right? So when you take your integral, if you end up with some kind of trig function of theta, hint, 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 you can use the triangle to come up with anything. X greater than 14. Oh, yeah, that's just, CJ, good question. That's just because they want it to be real. Sorry, I didn't even write it because I didn't even bother, because they put up here, guys, that x is greater than 14, because if x was not greater than 14, then when you took the square of it, it would end up with a negative number under square root, and they just don't even want you to deal with that. That's the imaginary number system. It's like a whole other thing, and we're not dealing with it in Calc 2. So that's all. Everybody else better? Here, I'll move it down. That's probably the part you have to write. So there's a bit more. There's about 3 more steps. I would say 3 or 4 more steps, but they're not hard. They're just, you know, plugging away. All right, cool. So if we're good there, I think we're done. Any other questions for the good of the order that people would want to see, especially people that couldn't make it or had to leave or anything? Any questions on what's coming due or anything? No. So these 2 worksheets, 8.3 and 8.4, are due for like submission tonight. Make them nice and neat. I cannot stress this enough. In 8.4, oh my God, like help me find, it should look like this. You should have your substitution and your triangle and your stuff. And then over here, you're doing your calculus work. Like it should follow that same pattern. There's a reason I gave you a page for each one of these problems. Don't cram it, make it so I can follow it nicely and neatly, because I want to give you the full credit. So make it so that I can by making it neat and organized. Good. Any other questions? Anything else for the good of the order? If not, then I will stop recording and then I can answer questions you have on. I would assume it's the sample exam that has more questions. than the exam, but maybe I'm wrong about that. So here we go. All right, so let me pause here. Wait, no, I'm resuming. That was when I wanted to pause. I want to do this.